So let me get going and say that I am Catherine Tucker, and I am going to be a little bit different from your other presenters in this series, in that I'm not a finance professor. I am not interested in financial instruments. Instead, I am a IO professor with a deep interest in technology and digital economics. And so what you're going to see today is how an IO professor or someone from that background thinks about how to approach studying blockchain. Now, before I go there, I must admit, for the paper I'm going to present, I have a lot of help. And I believe that Will has actually presented this seminar before, and he is very much a finance professor, so you've heard his viewpoint. We have Zhang, who's more like me, a technology professor. He's actually a marketing professor at WashU. And then we got Lu Feng, who is a new PhD student. And the moment I say that, you know that Lu Feng did a lot of the work here. So let's give him appropriate credit. Now, what are we going to be doing today? Well, I think the generalized question is this. Given how excited we are in general about blockchain, what can we say about its decentralized future? And I'm going to be using the example of smart contracts as a use case of blockchain. And I'm going to be tying that back to some general themes we have in IO about the diffusion of technologies. So that's going to be the general research question. Let's now go and remind everyone what a smart contract is, though, which is going to be the use case I'm studying in blockchain. And, you know, we hear the term smart contract a lot, but I've always thought the best way of thinking about it is as an if-then statement, which you put on the blockchain. And I think there's a lot of mystification that people have about smart contracts, but if you think of them as an if-then contract, it sort of makes a lot more sense. And so you put this if-then statement onto the blockchain. The wonderful thing, as we know, with the blockchain is that it's going to be both verifiable and immutable. We're going to have certain conditions of anonymity, but things will be automated. And so that's what a smart contract is from the perspective of an economist. Maybe what's more interesting is what is their economic purpose?
Can I interrupt?
Oh, go ahead. Go ahead. I was promised interruptions, but I wasn't expecting this quick.
Yeah, well, you don't know me, but I'll try to curb my, because you made this interesting characterization, the computer scientist and the blockchain expert in me, I have to jump and say,
of course,
you know, so I know if then that systems, and to a large extent, the whole point is to automate and to write a script that I can condition things happening automatically. And that's exactly what blockchains cannot do and smart contracts cannot do. So blockchains cannot wake up spontaneously once an hour or when conditions happen. They really have somebody from the outside world to send and inject a trigger. And then it can create the logic that you express as if that.
So I think I love your attempt to generate debate early on, but I think we're going to be exactly on the same page, because Perfect. What I'm going to be studying is that input, or as you're characterizing, the sort of more human element, which is how we think about how we evaluate when that if-then statement is fulfilled. So I'm going to be looking at, I'm going forward in my talk, but I'm going to be looking how you do the data provisions towards that if-then statement.
Okay, perfect. I will let you.
I would completely take your point that, you know, I think sometimes when you talk to people who are not blockchain enthusiasts, they just have no idea what a smart contract is. And I think they get an if-then statement. But I think the subtlety that you're emphasizing, which is it's not automatic. Someone has to do something, right, to evaluate whether the if is fulfilled. And I'm going to be all about that part. So hopefully I'm finding some commonality. And you put yourself on mute, so I'll take that as good. So let me go back to my presentation, and I was just going to make this economic point, which is that, you know, in the end, why do we think this might be important technology? It's because by having this sort of immutable if-then statement, which we have to agree on the inputs to, as Dalia's wisely pointed out, it's a sort of way of imbuing trust in contracts. And typically the history of Web 2.0, if you think about it, has been a history of having large platforms act as that intermediary. And the idea is that actually maybe we can still induce that kind of trust when we're making a contract through using a smart contract. So we sort of can relate it back to some standard economic terms that way. All right, so let's see if I can make the computer scientist blench again by my description from an economist's point of view about how I think about a smart contract. So the purpose of smart contract is to bypass these costly intermediaries, getting rid of that person in the way, whether it's the firm, you know, governing and I'm thinking about real estate titles, but we generally have some kind of costly legal process often in the way. And the idea is we're going to replace that. Now, what Delia was pointing out is that if you've got an if-then statement, you know, when you program up if-then in computer science, usually it's fulfilled automatically, right? We don't have to think about what the if is. But a lot of thinking about a smart contract is like, well, how do you work out if you're at the if? And the example I'm going to be thinking about today, the if comes about where you say, well, if a currency transaction pair, the exchange rate reaches a certain level, if that happens, we're going to execute the contract. Now, of course, you actually have to figure out whether or not that exchange rate between, let's say, a currency pair is going to be fulfilled. And to do that, you need data feeds. And the idea is I'm going to be studying those data feeds, which are going to go in. And then once the data feed says we're at this condition, then you execute. Now, you know, in general, I think economists who study blockchain as a technology are very excited about smart contracts. I think we're excited partly because it moves the conversation away from digital currency. And a lot of the applications we've been excited about, such as decentralized autonomous organizations or NFTs or these kind of vehicles are sort of, if you think about it, basically examples of smart contracts. Now, so I'm going to be studying smart contracts, but the next thing, you know, I promised you, it's not just smart contracts, but their decentralization. And you might say, well, why are you sort of throwing in this word decentralization? That's a little bit glib and jargonistic, but let me explain why I think it's important. You know, if you think, so I teach in a business school, if you think why it is that 4 years ago, 5 years ago now, all my students were blockchain all the time, it was because we were starting on the advent of what we call Web 3.0. And the premise of Web 3.0 was that we would be decentralized. I think there was a certain dissatisfaction that Web 2.0 ended up with a lot of large platforms which controlled and tried to, you know, and thrust themselves in the middle of a lot of interactions. And it just didn't feel quite like the promise of Web 1.0. And so as a consequence, we had this movement towards decentralization. And I've just got this screenshot here, which is sort of like the buzzwords around why we're so excited about decentralization. Now, smart contracts are obviously an example of that decentralization. And, you know, it's my duty to tell you, well, how widespread are they? This is like if you look at Ethereum and you sort of say, well, how many smart contracts are being executed? It looks pretty good. It's increasing, right, over time. But as a technology economist, that's not really the curve we expect to see, right? We're used to sort of more of an S-curve of diffusion, where eventually you have exponential growth, and we're just not seeing that yet. And one of the reasons why perhaps
Can I ask you a
I
question?
saw you took your mic off.
Yeah, I have a question. Yeah, can you go back? So this means like in any given day, how many different contracts have been used, but not like it could be like trading one that used like 1,000 times a day. I'm just curious because I feel like it seems that it's like maybe
You're worried I'm missing some kind of
active
margin
one.
of growth.
Yeah.
Is that right?
Yeah.
Okay, I think that's fair enough. I mean, I only honestly have this slide for this presentation, no. But I think if we cut the data in other ways, which we could, I don't think we're going to see that exponential growth. And the one thing I really want you to take from this, say for example, this was a chart showing the use of foundation models, right? We would have started to see exponential growth. But we just haven't seen that in the use of smart contracts. And that's somewhat disappointing if, like me, you're a technology economist who believes that this is also a general purpose technology.
Okay. So
I think your critique is well taken. There are different ways of measuring it. I'm just saying there's not been exponential growth.
Yeah, okay, good point. Now I'm curious to see it in a L2 chain.
Okay, yeah, we're about to get there because we're going to try and make some claims. Okay. Now, why is it that we may not have had exponential growth? Well, one of the things we're sort of saying is that, and it's not me who said this, is sort of more industry analysis, but people have pointed out there's actually a dilemma when it comes to using smart contracts, in that you want them to be scalable, you want them to be secure, and you want them to be decentralized. But at least so far, much like, when you're renovating your house, you can't have speed, quality, and price. We haven't been able to have all three together. And that's really quite disappointing when you sort of think about the promise of the technology, and it may be one of the reasons it hasn't taken off. And so let me actually get to now, with the big build-up, what it is we're studying. And what we're going to do is we're going to try and study, well, can we overcome some of these dilemmas? And we're going to be thinking about a way of scaling smart contracts using a layer 2 technology. And what do we mean by layer 2? Well, it's a fancy way of saying we're actually taking stuff which is layered on a blockchain rather than being on the blockchain. So we're going to study what happens when we start to take some functionality out of the blockchain onto a layer 2 technology. Now, we're going to be taking data from Chainlink, and Chainlink is going to provide precisely this kind of data that we were talking about to smart contracts. And if you remember what Delia was saying, she was like, well, but there has to be some kind of intervention, this if-then statement to execute. And that's exactly right. And we're looking at the source of data, which is going to form the threshold of whether or not a smart contract executes. Now, I should point out that Will, I think at the time, the reason we got access to some of this data is that he was involved, I think, as an economist, helping Chainlink. But we actually ended up redoing a lot of the analysis with data which was just public that we managed to get out of the API ourselves. So, but I do just want to warn you that Will had helped Chainlink. And probably when he gives his talk, he's very, very enthusiastic about Chainlink. I am enthusiastic about Chainlink because, they ran a really good experiment, which is great from identification, and they did something interesting, but, I don't have any ties to the firm, so I'm probably a little bit less enthusiastic. Now, what we're going to study, and the reason I'm excited and why I got involved, is that Chainlink did something very unique. In that previously, you could think of all of the data feeds they offered as being on-chain. And then in March 2021, they're going to switch it all to being off-chain. So I'll just tell you what the results are because we're economists and this is not a murder mystery. We're going to show that actually when you move stuff off chain, you can start to, it seems, resolve some of this trilemma, which is we had a slight increase in the accuracy of the feeds, but this was mainly coming from the fact that we were able to get more participation from different data feed providers. And then just in terms of scalability, unsurprisingly, the moment that you're not having to pay gas fees by putting things on chain, you're going to have a huge reduction in costs, which is what we saw. All right. Now, if you want to sort of have the headline of why we think this is important, it's basically saying, a way of thinking about why it is that smart contracts have not had the exponential growth we're hoping yet. Is perhaps that we haven't yet evolved sufficiently the complementary technologies such as this off-chain layer 2 technology, which can help us do all the things we want to do, such as cost reduction, decentralization, and data integrity. All right, that's the setup. Any questions before I get into a lot of details about what I mean by on-chain and off-chain?
So just to clarify, when you say off-chain, you mean L2, right? So we're not,
Yes.
Okay.
Yeah, I'm trying to, yes, by off-chain, I mean the layer 2 technology, which allows you to take something off the blockchain.
Right, yes, take some part of the transaction off, but at some point you're still the data sets.
Yeah.
Okay.
And
Okay.
maybe if I show you some diagrams about how much off the chain it is, it will sort of help you understand. Okay. So what is it that I mean by layer 2 off the chain, which is a very good question by Kite. And basically, at the highest level, if I was explaining this to non-crypto enthusiasts, I would say, look, we're basically studying a technology which is taking interactions off the blockchain. That's what it's going to do. Now, the reason we want to do this is that ultimately the very nature of blockchain is that things are fixed. And as a result, it just makes scaling stuff hard, right? We've intentionally put costs in the way and designed blockchains in order to make sure they're mutable and secure. But it is going to make, have these cost implications. And so, what could we do in terms of resolving some of these cost implications? Well, one thing we could do, if you think about it, is, well, we could increase the block size. But if we do that, that sounds a bit like we could have more decentralization. We can try and change how easy it is to discover a block, but that's risky. We can maybe sort of start to redesign the infrastructure. That's tough. And so what we're going to be talking about is what we can do really as individuals, or what we can do as a separate firm to resolve some of these problems. And this is what Kite was wanting. It's like, what do you mean by off-chain? I mean a layer 2 solution. And this is just what I'm going to be calling, when I say off-chain layer 2, think of those as synonymous. And the idea of a layer 2 technology is you're going to take stuff which you would have done on-chain to being off-chain. So let me just give you an example, and the math will make what I assume a lot of the theorists laugh on this, who are watching this. Let's imagine we've got Alice and Bob, and Alice wants to send Bob to Ethereum. Now, of course, Alice could send 2 transactions to Bob with 1 Ethereum each. Or she could have a combined transaction and send the 2 Ethereum together. And basically, you can sort of see the moment you start to combine transactions and then put them on chain, you save money. It's really that easy. We're not really sort of saying, but we're saying the combination of actions before you use them as input or as an action is going to save money. And the basic idea of this combination or layer 2 technology is that we want to save gas without sort of sacrificing data integrity. Because why was it we ever had this idea that Alice was to do the 2 transactions on chain to begin with? It's because we thought there was a lot of integrity. Now, what is it that Chainlink does? Chainlink is making real-world data available to smart contracts. As I said, the typical example would be the exchange rate of a currency pair. Now, Chainlink has a lot of terminology. And if you've ever read any of their white papers or anything about this space, it is almost baffling to an outsider. So one of my big jobs in terms of writing the paper was to try and use everyday language that someone who's an outsider might understand. And the way that Chainlink describes what it does is it describes itself as a decentralized Oracle network. And one of my big things when I wrote the paper was to make my co-authors actually explain what they meant by this, which is that it's a data feed. Basically, they're supplying data, and Oracle is a data feed provider, and you're trying to decentralize the number of data feed providers that are providing inputs into these smart contracts.
Can I say something?
Of course.
I think just maybe clarification to some people that I think in terms of smart contracts, like the example that you gave about the cost, it's even higher because when you want to run a smart contract, you need gas units. So it's not like just a transaction. So the more complex the smart contract, it's very expensive to run it in a kind of and it's even make it be like 10 times more like
Yeah, I mean, just for example, let's imagine as well as Alice and Bob,
yeah,
we added into that 10 data feed providers that are going to supply the data for the if-then statement between Alice and Bob. That's not just 2 gas fees you're saving, right? As you say, it's 10, 12. I mean, this is a huge amount of money potentially that we can save. Now, this is how Chainlink describes itself. I mean, what's notable to me is just how fast they've grown since 2019. You know, they're one of the biggest providers of data feeds or decentralized Oracle networks that operate in this space. And, you know, given that all my empirics are going to come from one layer 2 technology, I think with this slide, I'm trying to convince you that they are a big deal. I mean, they are processing tens of billions of dollars in smart contracts. So it's sort of you know, this is not obscure. This is something big to be studied. All right. Now, so let's talk a little bit more about exactly what they do. So, you know, as Nia was wisely pointing out, it's not just Alice and Bob. Chainlink's involved in this smart contract. And if you think about what your job is, if you're providing a data feed for a smart contract for a currency exchange pair, is that you have to be constantly updating it, right? And a lot of what Chainlink's been trying to do is to work out, well, how do we update it? How do we recognize when a data feed is stale? And so what they're going to be doing is they're going to be trying to come up. We've got all these data feeds. They're going to be updating over time. Chainlink's got to have a process to work out, well, what is the truth? Given we got these data feeds, what is right? When is it stale? When should we be executing this smart contract? All right. Now, let's talk a little bit about exactly the transition I'm studying in this process, which is that when Chainlink started off, all of these data feed providers, these decentralized oracles, would provide their answer to say what the Ethereum USD currency pair was to the blockchain. And then the smart contract would be aggregating and then executing. And I mean, this sort of basically stole my thunder. The moment you hear this is a lot of gas fees on Ethereum, right? Now, what they're going to do in March 2021 is they're going to completely change what they did. Rather than doing this aggregation and consensus building on chain, you're going to start to do it on a peer-to-peer network off the blockchain. And you're going to have all these oracles or data feed providers submit their answer. And then you're going to randomly choose one of them to take the consensus and submit it to the blockchain. Now, that's what they're going to do. I guess I can show you some pictures. This is partially for Kira, I think was interested. I've got my Ethereum USD currency pair example. And you can see there, if you're doing it on chain, you know, in this example, I've got 21 data feed providers. They're going to put in their current beliefs about what the true currency exchange rate is. And that's all happening on chain. Now, by contrast, off chain, what's going to happen is rather than having all the 21 currency providers submit and of course, you know, be very expensive. Instead, what you're going to do is you're going to randomly select one of the, you're going to have a peer-to-peer network off chain, and you're going to choose one of them to submit the consensus or, you know, the median here towards chain, thereby, you know, in this case, basically saving, you know, you've gone from 95, you know, you've reduced your gas fees almost by 95%. So that's going to be basically what we're doing. Okay. Now, I'm just going to pause here because I worry I may have over-explained something which is rather obvious in case there are any questions about this process.
Just from curiosity, the updating rule is the majority, it's the wisdom of the crowd, like how do you pick?
So the submitter is randomly selected.
Okay.
And then they have to be endorsed. And so you can, you know, I think it's an interesting question of mechanism design. I'm not a theorist, but it seems to me pretty robust if you sort of think about incentives.
Okay.
Right. Now, we're going to get to the bit I'm excited about, which is that, as I just admitted, I'm not a theorist who thinks about mechanism design and the incentives of truth-telling. Instead, I'm an empiricist who is interested in how this affects the fusion of the technology. And so we're going to have this new regime, which is introduced in, sorry, I think I said March earlier, May 2021. Now, what is going to be amazing for us is this. Chainlink was really nervous about this. I mean, this is scary, right? You are a data feed provider to folks who really believe in blockchain, and you're taking your transactions off or your data feeds off blockchain. Therefore, what are you going to do, given that, you know, you're well-funded? You're going to run two systems. And so this is what they're going to do. They're going to run the new system and the backup system at the same time. So we're going to have the old on-chain version and the new off-chain version. And that's going to allow them to run almost the perfect horse race for each instance about how it's operating and how it's actually going. Now, as I say, the reason I got involved as an empirical economist is this. When we talk about identification, you know, if you think about the sort of Rudin's framework, which we will learn in applied macroeconometrics about observed outcomes, the essential problem is that you can never really evaluate a treatment effect because you don't observe the same unit being treated and not treated. But we literally do that here, right? We can see treatment and non-treatment. And I can't tell you how awesome this is empirically. It also means that in some sense, I could just show you everything in tables and point estimates. I'm going to show you some regressions just because we felt we had to. But really, the identification is, for me, you know, some of the cleanest I've ever seen. Now, of course, as I say, we've got these regressions and these, you know, every data feed blockchain fixed effects when we run it, but it's still, the identification is really coming from these parallel systems. All right, so you remember I told you about our amazing PhD student who worked with us on this? Well, this is where you can tell they did a lot of work, and that we're going to use a whole lot of different data sets to try and evaluate how this is working. Because we did, as I say, you know, I think everyone has more comfort with the project when we're not just relying on what Chainlink's telling us about. And so we're going to have data at the blockchain data-free date level. So that's really quite specific. If you think about it, it's going to be very granular data. And we're going to know the fee that is being paid. Now, for data accuracy, we had, you know, we want to have a sort of ground truth. how good is the data feed, we decide to use the match to actual realized Binance data. We can talk about how comfortable we feel with that, but from what we can do with spot checking, it seemed to be a pretty good source of truth. We're also going to have the number of data providers in each round. And that's going to be important because a lot of the mechanism is going to come from shifts in that number of providers. And we're going to study this May to September period, which I'm going to call a transition period. Why? Well, that's when we have these parallel systems. So it's not going to be sort of diff and diff before and after. We've literally got treatment and control happening at the same time. All right, so as I said, I can actually just show you everything really in a simple chart. So unsurprisingly, and I think Nia got this right immediately, there's just a huge reduction in gas fees. Very large, right, in terms of how much you're paying. When it comes to accuracy, there's absolutely no change. And remember here, we're talking about accuracy as deviation from what the actual realized transaction was on Binance at the time. But we're not going to see anything. I'm going to pummel those 0.003 numbers and try and find something. But, really, there's not that big a change. Now, one of the things that is happening, and, is perhaps why we don't have the 95% drop in gas fees, is that we have a huge increase in the number of providers per round. And we're going to say that's going to help us a lot to sort of think about the accuracy of the system. All right. Now, I've shown you these results, and I'm now going to just show you regressions of lots of fixed effects, which show you exactly the same thing, but mean that you don't have to do a subtraction. And so what you can see there is that we do have this huge reduction in gas fees. I mean, gosh, what we are studying, I don't usually study stuff like this, saved this one company, Chainlink, $260 million. I mean, this is huge when you think about launching a new technology, barriers to entry. This is just amazingly good news. And in some sense, it's very straightforward that when you have things on chain, it's expensive. And when you move stuff off chain, it's less expensive. But this is, sizable. I want to give you the sort of magnitude of it. Now, you remember I told you I would torture that increase or that shift in accuracy. And I tortured it. And if you look really, really hard, there is a slight increase in accuracy, though I do want to say that that is small in magnitude. That may be important if you're doing currency trading. It is less significant than some of the other things we look at once you put in all the kind of controls you might want to. Again, for us, the other thing which was important was that in this new peer-to-peer network off-chain, we were able to, because we reduce gas fees, we were able to pay more data providers, guess what? And as a result, we have more of them in there. And remember, this is important because we want things to be decentralized. Previously, right, we sort of had 8 data providers. Now we've got 16 on average. It's like it's like we're moving towards having a more decentralized system. Okay.
Can I ask a question?
Those are the big results.
So during this period of time, there was a parallel in L1 and L2, right? They work both. And so this result shows like for a given period of time, both L1 and L2, right?
That's right.
But my question is, today they kind of kick out L1 and they just use L2?
Yeah.
So maybe now you can even have better results because the L1 providers will move to L2. So once you have more providers, it's even can be more precise, the price accuracy. Or
I like the way you're thinking. I mean, honestly, we haven't looked at that.
okay.
I think I was just so excited about my identification.
Yeah, I see. Yeah.
That when I didn't.
No, I know.
At that point, we're going to be, if I was to say, Chainlink's doing even better now, but that may be for many reasons, right, as well as this.
Okay.
But I think you're probably right. I just don't have any empirical proof of that.
Okay. Thanks.
Anyway, I actually have good news in that I'm getting to my punchline, but I also have bad news in that my punchline is going to involve a long lecture about technology economics. So unlike most economics, usually when you get to the punchline, you're done. I'm not done at all. So, I had a big setup, and then the empirics were so straightforward because of the experiment, that I can just show you the results almost in a table. What we did, remember, is that we studied what happens when you move the provision of data feeds for a smart contract from the blockchain towards a peer-to-peer platform, which acted as a layer 2 technology and was an alternative. As I said, excited about the identification because we have both treatment and control. We found, if you torture the data, the accuracy of feeds slightly increased. We have some evidence, it's not the strongest of evidence that any accuracy we saw came from the fact of having more data feed providers. That doesn't surprise anyone who knows anything about statistics. We're excited, I think, more just not just to the accuracy, but just this, this idea we're sort of moving away from a centralized world where you just have a few data providers. And of course, right, the great thing and the reason that Chainlink has now gone completely layer 2 is that they save 76% when using the new technology with layer 2 technology without any real reduction in service of the quality of what they're doing. All right, so, if my co-authors were to present this, they would say the following. They're very excited about this. They would say, oh my gosh, it's absolutely amazing. We have this. We show that using a layer 2 technology resolves blockchain trilemma. We can reduce costs. We can have decentralization, and data integrity is not affected. This seems brilliant. And so the idea is that these layer 2 technologies can help us achieve the promise of blockchain, which is this decentralized scalable trust. Now, this is why I say my co-authors like the first 2 bullet points. My big point as a technology economist, which is less popular amongst my co-authors, is but we're doing this by moving away from the blockchain. I mean, we're saying that we can only make the blockchain work when we take stuff off the blockchain, and there's got to be some questions about that. But I sort of resolved it for myself this way, which is that ultimately, when you study the diffusion of technologies, what we've always said is, say, taking the canonical example of electricity, is initially we just don't know really how to use a new technology. Initially, electricity, its usefulness was for lighting and replacing steam in factories designed for steam. And it was only really when we reorganized the entire process and evolved machines that could use electricity that it really was a general purpose technology. We saw efficiency gains. And maybe this is just what we're finding here, right? Perhaps we've been just so enthusiastic by, we're so excited about blockchain, we've almost been too pure that everything has to be about this particular technology. But really, we know from the evolution of other technologies that they only have efficiency gains when other technologies evolve, which are complementary. And so, I would say that though you might take my results sort of very negatively about blockchain technologies, I would argue that this just is what we'd expect as a technology economist.